All, this is Harini. Welcome back to our YouTube channel called with Harini. Today we are going to solve day 7 of Leetcode challenge, maximum number of events that can be attended. So if you look into the problem statement, you are given an array events. So they will be giving you an array of events. So whose start date and end date. Okay, like this they will be giving. So every event starts at the start date and ends at the end date. So we can add an event of I on any day, which means so 1, 2 they have given, you can attend on 1, 2, 2, 3 you can attend on day 2 or day 3, and 3, 4 you can attend on day 3 and day 4. So, but you can attend only one event at any time. So we have to return the maximum number of events that we can attend. Okay, so if we look into this example, see, the event 1 to starts. We have attended the event on day 1. So this on day 2, this on day 3. Still day 4 is left, but we don't have any events. Yeah. So like this. So we have attended maximum 3 events exist. We have attended maximum of 3 events. But in this case, if you look into this example, we have attended this. We would have we would have traversed like this. We would have attended the first event on day 1, second event on day 2, third event on day 3. But on day 4, if you come, this event can't be attended. So what from this we would have understood, but the answer is 4. The thing is, we could have attended this on day 1, this on day 2, this on day 3, this on day 4, because like that only it exists now. You can attend it on any within any start date to end date, right? So for this, what we can do, whatever the earliest start, if we would have sorted this array, maybe I can show example. So this is the original array they have given, right? So if we would have sorted like this, 1, 2, 1, 2, 3, 3, 4. So we know maximum number of days will be the max, right? So we could have attended this on day 1, this on day 2, this on day 3, this on day 4, so that we could have accommodated all the events and we could have returned it. We should have returned the maximum, right? So the maximum will be 4 here. So like this. So how here what they have told, here we can attend only one meeting at any day, right? So here we can choose the greedy approach, because once we sort, we can take any meeting at any day. So we based on the days and based on the interval. So this is a day 1. Whatever the events that is present, if you would have put it in an array, for example, on day 1, let's assume I'm traversing through the day 1. What are the events that is available on day 1? We have 2 events, right? And so what are those? You just put it into an array. Okay, 2, 2, 2. So at this particular day, you can attend one event. So what you would have done, you would have taken this one event out. So still the 2 would have been there. So on day 2, when the day 2 comes, already 2 exists, you could have added on day 2 what we can have. We have another what all the events that is available on day 2. So because you should not add these two, because already these would have added at the day 1 itself. So you should add what is lesser than, so we should add whatever the events start date should be equals to the I. Okay, so on day 2, what all the events available? Only 1. So now in this array, let's assume we have 2, 3. So whatever is less, you should pop it out, or whatever is less than that particular start date, you should pop it out, because that you can't attend. First, for example, if we would have had, uh, for example, 1 comma 1 something okay, let's assume we have 1. So the at that particular previous array, this is correct, but when the date 2 comes, this is invalid, right? So what we should have done, we should have popped it out, which is not required, because that even anyway can't be attended, because we have moved to the day 2, still previous some event exists. That's what matters. So that we can't attend. Okay, I hope why we are in that, we have to check that as well. If something is lesser than whatever the current day is, also we should remove. If not, what we have already, we have to write, so that you can attend at the day 2. Now we will be popping this out on the day 2. So now the max got incremented to 2. We have popped it out. And now the day 3 comes. On day 3, we would have seen what all the events that are available on the day 3. This exists, right? So why we are not inserting that particular start and end means we don't need the start, because on each day only whatever the events that is available on that particular day we are pushing. So we needed only the end date, so that whenever the particular start date crosses the end date in this array, we will be popping it out, or we will be adding it to the events, that so that we can attend. Okay, this but on day 3, what are the events available in this, that you can attend only one, because that's a greedy approach. It's only what, so you should pop which is smaller out of that. Okay, so now when we are attending this, we will be adding the 4 into the array. So when the day 4 comes, you would have popped. So this you would have attended and added to the max 3. This you would have on the day 4, you would have popped this out and added to the. So now you understood how the sorting and why we need to take the minimal on the top, so that this can, for example, if you pop whatever available, this 3 and 2 would be not comes into not attended, right? So whatever the smallest you should pop. So since smallest you should pop, you can't traverse through each time whatever the exists in that array, so that it will be again order of n time complexity will be coming to just traverse uh, through the array. So what we can do, traverse through the array and to find out. So while inserting itself, if you use priority queue, you can pop it out smallest element at the order of n, right? See, order of log n, because priority queue takes time complexity order of log n. So what we have to do is, we have to just while inserting and popping out, we will be just using the priority queue, so that it will always pop the smallest element in the queue, even if the day exits and the smallest element lies on. If you use priority queue, that would have been popping it out. I hope this makes sense why we are using priority queue and how insertion and deletion works based on the days. So basically what we have to iterate through the number of days from 1 to the maximum. So first we have to find out the maximum days. So maybe I can just go through the pseudo code so that it will be easy to understand. So the max events. So we will be having an events array. Correct. So now we should have sorted. I have explained why we should sort. Now we have to get maximum max day. That max day will be from the events of 1, right? For event in events. So among this we have to find out the max. Okay, so this max will give you whatever the maximum Then what we are going to do, we will be traversing. Then we will be traversing for day in range 1, max p plus 1, because we have, for example, if the max is 4, we have to traverse, the range should be 5, right? So 1 to 5 like that, so that it will be traversing till the max t. So now we will have another, let's have the max event variable to 0, and we will traverse to another j, will have 0, will have all this values as a 0. Then we will be traversing through this array. N is nothing but length of the events. Okay, so what does this mean is, whatever the particular day, for example day 1, so this is what contributes to the day 1, right? So whatever, we will be traversing through the j, we will have the j pointer. So if the day 1, what are the events that is available in this array, in the array that has a start day as that particular day, add it to other corresponding end day, we will be adding to the queue. So while j less than and events of j of 0, correct, less than or equals to I, and we are using periodic, right? So we should have another priority queue as an empty. So PQ, comma, whatever the events of j of 1. Okay, now we are having the j pointer keep on increasing. So why we are keep on increasing? So that for the next time the j will start here. We don't need to traverse this queue, because at this itself we would have added to the queue and we would have verified everything. So we need from here. So jth pointer will just traverse the array once among the days. Okay. So also why we are using the priority queue, you can append it here. So then again, until priority queue is there, and priority queue 0 will always hold the smallest amount, less than or equals to I. Sorry, less than I, equals also we can use. I is nothing but here the day, right? So I'll have. So whatever, for example, your day is 2. In that array we have 1. So on day 2, can we attend day 1? No, right? So what we have to do? We just need to pop it out. Pop of PQ. So we are just popping it out. That's it. So next, still if the priority queue is exist, so maybe it might have another 2, 3 something. So now we have popped this out. Okay. Still we can attend this event, right? So then what we can add, we can increase we can just pop that for event, because it got attended, so we no need to. So max event plus or equals to 1. Then return the max event. So now here if we wouldn't have used the priority queue, okay. So for example, if the array is like this, whatever you have added like this one, it will be there. So if it was like this, so we have to traverse through the array, whether we have to check day equals to, whether this is less than, or this is less than or equals to day, or this is less than or equals to day. Then we have to pop it out, right? So it will again traverse through order of n. So to avoid this order of n only, we are using priority queue. For that we will be having only log of n for insertion and pop out. That's why nothing else. I hope I hope this makes sense. Maybe I can just try run the example. Okay, let me take this example and see where I can add the example. Okay, now let me take this example. 1 comma again 1 comma 2 again 2 comma 2 then 2 comma 3 3 comma 4. Okay, one we have seen why we need sorted. Now I am going to say why we need to copy. So here 2 comma 2. So what you would have done, this you would have attended day 1, this you would have attended at day 2, this you can't attend because see 2 is already for day 2 you would have attended this event. Anyone if you attend this or this also the same, you can add only one point. So with this you can't attend, then this you can attend on day 3, this you can attend on day 4. So maximum you can attend 4. Let's look into the pseudo code how this works. So already I have given in the sorted array, so this doesn't make sense. Okay, this would have written this won't do the sorting. Then max day, what is the max day here? The same 4. So now j equals to 0, max events equals to 0 for now. So now day equals to 1. At 1 what you can do, what you can append at 1, what are this, so you can append 2 comma 2 to the heap. So then if you see which is both are less than or equals to I, right? But if here if it goes, this will be greater than or equals to I, so greater than I, so j will go to 0 1 2. So now if you see the priority queue, day is 1, which is less than this 2 or less than day 1, no, so it won't pop. But here if you see this, now we are going to attend this at day 1 because we would have inserted based on the start date, whatever the start date, the day I is nothing but here the day, maybe I can whatever the day we would have inserted into the priority queue only if the day comes. So we will be verifying the end day. Either you can attend it this on day 1 or day 2. So that's why until day 2 comes, we will be having it to the queue. Or if you are attending it at the day 1 itself, what we are going to do? Here, the first event you are attending at the day 1, so and you are popping it out. So here, if you also see, we have attended it on day 1. Okay, so for day 2, we have still have 1. So again, when the day 2 comes, so what you are going to do? We are going to append this and this, right? So again, you are going to append those. Another 2 comes and another 3 comes. So now if you see here, the previously we have added 1 day, right? So that is also there is nothing on top, is now the day is 2. There is nothing in the priority queue that is less than the day, so we will be just updating the max event to 2. Already on day 1 we have updated it, so now the max event is 2. So now the day got updated to 3. This would have popped out here. Okay, because this event we have attended, so we are popping it out. That's it. So on day 2, now the day 3 came. Day 3 what can happen? Okay, now we have one more event at day 3. So what we are going to append at day 3, 4 we have. But if you come to this condition on day 3, can you attend any event that is ending on day 2? No. At any particular day we can attend only one event. So this won't work. So we are popping out this. For this only this condition exists. Periodic Q on top, which is less than or equals to day, we are popping it out. Okay. So now the another which is on top is equal to the day 2, day 3. So we are be popping it out and we are implementing the count to 3. Next, when the day they got implemented to 4. Now if you see it, then now the j would have came here at the end of the array. J is equals to n. J, I didn't update everything. The j equals to, they have reached 5. So 5 is end of the loop. We won't be adding anything into the array. Then we are seeing on top whatever the periodic smallest is it less than or equals to day? No, 4. So it's not equal to say this event also we can add them. So then the max event got updated to 4, and the day this is the maximum day rate as per the code. Max day is also 4. So yeah, till max day 4. This is the max event, so we will be returning this max event. I hope you guys would have understood. So if you look into the time complexity, we are sorting. So that for the end login plus we are traversing to each day max day. So let's assume the max day as d. Okay. So d, and for each d we are pushing that array, pushing into the priority queue and popping it out, right? So that popping it out will be taking order of 1, but pushing will be taking log n. So that d into log n to the map. So we what? So n plus d of log n is the time complexity. So we are storing it in the heap, right? So priority queue will be order of n. This is the space complexity. I hope this you guys would have understood how the pseudocode works. Now we'll just look into the solution. So if you look the same thing, we would have find out the max day, and sorting, we know why we are doing sorting, as well as traverse through the max day. The same, whatever I have explained in the pseudocode, the same I also written here. I have clean. I think I have given enough explanation for why we are using priority queue, so that we can, instead of order of n, we can have log n. For pushing and popping will be done in order of 1. So that there we have to do order of 2n for each push and pop. So that's why I'll just run through this. So this is okay. This is the solution for this. I hope I have made enough understanding for you guys to each and every step, why and what is required. I'll be giving all the solutions, all other languages solutions in the GitHub. Maybe if you still feel that you need to debug and see, you can just use those and get a better understanding by debugging. And yeah, thanks for watching. If you need further explanation for anything, or if you didn't understand at any point, please feel free to leave a feedback so that I can improve myself better. Always welcome for having the best critic comment. Yeah, if you like my video and my explanation, do like, follow and subscribe. Thanks for watching.